In this video, we are going to graph the system y is greater than x squared plus 2, and y is less than or equal to x minus 5. Now, in the previous video, I kind of talked about this, and I said I would write it down, and here's a perfect place to put it in your notes if you'd like to. And what this is saying this at, if the inequalities are solved for y with y on the left, like these are, so y has to be all by itself on the left-hand side, then you can use the inequality symbol to tell whether you should shade above or below. So you don't have to use test points in this case like we did in the previous example over here. So notice these inequalities are not solved for y, so we couldn't use the inequalities to judge that. However, and that's just because y could be negative, which would flip the inequality. In this case, it wasn't, so we were still okay, but I used test points just to be sure. In this example, however, y is by itself over here, so we can use these inequalities. So this inequality is greater than, which means we'll shade above. And another thing that inequality tells us is because there's no equals to, the parabola will be dashed. And I know that's a parabola because x is squared. Now for the second inequality, because it's less than or equal to, we'll be shading below, and it will be solid because it does include the equals to. And the second inequality is a line because x is to the first power. So let's start with the first inequality, and we'll graph the related equation as a boundary. So this is a parabola, and let's talk about transformations with this one. It's pretty easy. This plus 2 is not in there being squared with x, so that means that's a vertical transformation, and it's a plus 2, so it's a vertical shift up 2. Now that just tells us where the vertex is. So remember the parent graph would be here, and the vertex shifts up 2. We need another point on there. You can get that by either shifting, I don't know if you remember, but the parent graph is 1, 1, and we can shift that up 2, and we can reflect that point over here. You can also get that vertically if x is equal, algebraically. I told you I was tired. If x equals 1, that's going to give me y equals 1 squared plus 2, or 1 plus 2, or 3. So we know the point 1, 3 is on the parabola as well. So when you're graphing a parabola, you need to know the vertex and at least one other point so you know how wide to make that parabola. All right, so remember, this parabola is dashed because there is no equals to. So when I go to graph it, I'm going to graph it with a dashed curve. All right, now let's look at the second related equation, which would be y equals x minus 5. This one is in slope-intercept form. So remember y equals mx plus b. So our y-intercept, b, is negative 5. So we're going to have the point 0, negative 5 on the graph. And then our slope is a number in front of x, which if there's nothing there, it's understood to be 1. So we can graph the point 0, negative 5, which is here. And then from that point, we can walk out the slope by going up 1, over 1, up 1, over 1. And this is a solid line, So we're going to graph it with a solid graph. Another way to think of this, if you're thinking of transformations, it is a line that was at the origin, but now it's been shifted down 5. All right, so now it's time to start thinking about shading. In this case, we need to shade above the parabola, which remember would be inside here. We need to shade below the line because it was less than, which would be down here. And when you're solving a system, you're going to see where those two intersect, and they do not. What that means then is that the points that work for this inequality, the top one, do not work for the bottom, and vice versa. So although those inequalities have solutions when they stand alone, if you try to put them together as a solution, there is no intersection, so there is no solution. So let's make a note of that. So since the shaded regions do not overlap, there is no solution to this system. So in Alex, or for me, you would just say no solution. So the shade, what we have graphed here is not the solution because there is no solution. Now, let's go ahead and look at this last example because it is the same system with the inequalities reversed. So in this case, let's go ahead and graph our two graphs again. So remember, this first one is a parabola shifted up 2, and I can take that point that was here and shift it up 2. And it's still dashed because it does not have the equals to. Okay, and then the second system is the line that's been shifted down 5. And it's still solid because it still has the equals to. But now let's think about shading this one. So this one is less than, so we're going to shade below the parabola. So that would be down here. And then for the line, it's greater than, which means we would shade above. So that would be above here. And where they intersect is outside the parabola and above the line. So kind of that region that has both the green and yellow. So when you're graphing, we need to clean this up a little bit. So I guess I can do this. Nope. So what I'm going to do is I'm going to just then, to show the solution, I'm going to just shade the part that is both below the parabola and above the line. So this yellow shaded region is the solution to the system. Now I'm going to do one more video to show this in Alex, and I will put the link I'll put the link to that video down below.